Students, get ready, take your place, keep notebook and pen, look at your phone screen. If this session ends, we will continue with the same link soon after this class. So note these points, everybody. Still I am getting sound. Everyone mute your device, look at your phone screen. You get sound, listen sound. Take convenient place. Look at your phone screen, students. Let's recall what we studied in the previous class, students. I take to you to the screen. Look at there on your phone screen. You get the topics of previous class. Yes. In the previous class, we studied about the concept of critical angle. You can see on your phone screen. The main point related to critical angle is light ray passing from denser medium to rarer medium. Look at this, students. We studied about this already. This is a ray diagram showing the concept of critical angle. And look here. In the place of angle of incidence, see critical angle is written. An angle of refraction is equal to 90 degrees. Above you have a definition of critical angle. When a light ray travels from a denser medium to a rarer medium, if the angle of refraction in the rarer medium is 90 degree, then the corresponding angle of incidence in the denser medium is called critical angle of that pair of media. Students, we studied about critical angle. For the condition is light must pass from denser medium to rarer medium. This is the ray diagram for it. You can see light is traveling from denser medium. When trying to enter rarer medium, but it passes along the interface. In such case, angle of refraction is equal to 90 degree, and that angle of incidence is called critical angle. Here you have ray diagram and also definition of critical angle. This also we studied in the previous class, students. You can look at the ray diagram. Whatever points I am telling you, you see at the screen, your phone screen. Ray diagram, in the ray diagram, IC is written. IC means critical angle. For that angle of refraction is 90 degree. There are two medium there. One is glass medium and the one is air medium. Right side top, the angle of incidence for which refracted ray makes an angle of 90 degree with the normal is called critical angle. Critical angle is denoted by C. Final formula, look at there. Final, very last. Sin C is equal to N2 by N1. Sin C is equal to N2 by N1. Here N1 is refractive index of first medium. N2 is refractive index of second medium. C is nothing but critical angle and sin is the trigonometric function. This all we studied in the previous class, my dear students. Understanding the concept of very important to understand the next topic. To understand this topic, you need to understand the critical angle. See, where is the refracted ray in the ray diagram? It passes along the interface. Refracted ray passes along the interface touch అవుతూ పోతా ఉంది refracted ray. This is also a ray diagram for the critical angle. Sir, Ramanji sir, so much disturbance, TV sound వస్తా ఉంది sir. Please remove that child. And note the name, sir. I call later. I speak to that boy's parents, sir. Please note the name. I cannot go to the participants list because I am on the screen sharing. Yes, students, sorry for the disturbance. Once again, concentrate. Look at your phone screen. Okay, you are looking at the critical angle ray diagram. In that you can see I is equal to C. For that angle of refraction is 90°. Also you can notice light traveling from denser medium to rarer medium. This condition must be followed in the case of critical angle. This all we were studied in the previous class, my dear students. Today we take another topic, very interesting, very applicable topic, very interesting and very applicable topic. The topic is, you can see on your phone screen, total internal reflection, shortly called as TIR. First letter తీసుకొని చెప్పొచ్చు, capital T, capital I, capital R. TIR, total internal reflection. Look at this slide on your phone screen, students. Very colorful one. Left side first one, diamond. డైమండ్ వెంటనే మీకు మైండ్లోకి వస్తుంది, చాలా మెరిసే ఒక మెటీరియల్, షైనింగ్ మెటీరియల్ అని మీకు మైండ్లో వస్తుంది. మిడిల్ వన్, మిరేజెస్, MIRAGES, తెలుగులో ఎండమావులు అంటారు. ఎందుకు కనిపిస్తాయి లేకుంటే ఎందుకు ఏర్పడతాయి? నెక్స్ట్ థర్డ్ వన్, దెర్ ఇస్ ఎ కేబుల్, ఇన్ దట్ ఫైబర్స్ ఆర్ దేర్ కాల్డ్ యాజ్ ఆప్టికల్ ఫైబర్. So in all these places, some idea is giving to you, which you have in your mind. You might have seen all these figures at various places in your life, students. Now look the question. What is the reason behind the shining or brilliance of diamond? What is the reason behind the shining or brilliance of diamond? Diamond యొక్క షైనింగ్ లేకుంటే బ్రిలియన్స్ కి కారణం ఏముంది? Let's know answer for this in this topic. You have one more question there. What is the reason behind the formation of mirages? Mirages ఫామ్ అవడానికి కారణం ఏమి? దానికి రీజన్ ఏమి? ఎందుకు ఎండమావులు కనిపిస్తాయి? ఎందుకు ఎండమావులు ఏర్పడతాయి? What is the reason behind that? We will also know answer for this question in this topic, student. One more question posing to you. What is the basic principle? Basic principle, not reason. What is the basic principle behind working of optical fiber? ఆప్టికల్ ఫైబర్ మీకు కనిపిస్తూ ఉంది. ఈ ఆప్టికల్ ఫైబర్ పనిచేయడానికి ఏ సూత్రం పైన ఆధారపడి ఉంది? వాట్ ఈస్ ద బేసిక్ ప్రిన్సిపల్ బిహైండ్ ద వర్కింగ్ ఆఫ్ ఆప్టికల్ ఫైబర్? We will know answer for all these three situations and three questions in this topic, student. So the present topic is total internal reflection. You might have got answer for the three questions also. What is the reason the first two? What is the principle behind the third one? Is nothing but total internal reflection. Now we need to know what is total internal reflection, students. Everybody pay attention, look at your phone screen, concentrate, listen my voice, listen my words. Whatever I tell, look at your phone screen. In the based on ray diagram, we understand every concept here, student, because light chapters, whichever light chapters are there in 10th class, all those chapters can be understood only with the help of ray diagram. కేవలం రే డయాగ్రామ్ ఉపయోగించి అన్ని కాన్సెప్ట్ మనం అర్థం చేసుకోవచ్చు. అందుకనే రే డయాగ్రామ్ చాలా ఇంపార్టెంట్. రే డయాగ్రామ్ తోనే మీరు అన్ని అర్థమైపోతుంది, నాట్ విత్ సెంటెన్సెస్. కేవలం సెంటెన్స్ తో మీకు అర్థం కాదు. దట్స్ వై let's understand the concept of total and internal reflection with the help of the ray diagram. Look now, there is a question, there is a point at the top. What happens to the incident ray of light, incident ray of light, when it makes an angle which is greater than critical angle? Which is greater than critical angle? Students, in the previous class I gave you the values of critical angle of some materials. Critical angle of water, critical angle of glass, critical angle of diamond. Critical angle of water you wrote already. Critical angle of water is 48.6 degrees. And critical angle of glass 42 degrees. You can note down these values. And critical angle of diamond is 22.4 degrees. Because knowing the values of critical angle is very important. There is one question to you on the screen. What happens to the incident ray of light when it makes an angle which is greater than critical angle? For example, ఇప్పుడే చెప్తున్నాను వాటర్ యొక్క క్రిటికల్ యాంగిల్ ఎంత 48.6 degrees. That is the angle of incidence value. If the incident angle of incidence value is 49 degree, then what would happen? What would happen is, let's see there. We consider two medium. Down everything is written there. Denser medium, which is a glass slab, and rarer medium, which is a air medium. And refractive index of denser medium is N1, refractive index of rarer medium is N2. So two mediums are considered. Next one. We have drawn 5 normal rays there. 5 normal rays are taken at different places on the paper. This is all we are doing on a paper by taking glass slab and air medium. Black vertical lines are normal rays. Now, first normal ray is taken. Light ray is passed without making any angle. Where is the refracted ray? Passes along the normal. So there is no deviation. Next one. Now look at the angle of incidence. For example, this angle, some angle is there. Look at the refracted ray. It bends away from the normal, and note the angle of refraction. Next, third one. See the third ray diagram. Angle of incidence is increased compared to the second one. For that, what happened? Where is the refracted ray? It bends more away from the normal. Angle of refraction increases. Next, fourth ray diagram. Further angle of incidence is increased. We are using the glass slab. Light is traveling from denser medium to rarer medium. I told you glass slab refractive critical angle is 42 degrees. For example, there, angle of incidence in the fourth ray diagram, angle of incidence is 42 degree. Then where is the refracted ray? It passes along the interface. Look at the same fourth ray diagram. Now the changes from this one to and this one is here showing angle of refraction is equal to 90 degree. It means the fourth ray diagram is related to critical angle. We are using glass slab, which is a denser medium. Glass slab critical angle is 42 degree. అంటే ఇన్సిడెంట్ రే 42 యాంగిల్తో ఇన్సిడెంట్ అవుతా ఉంది. అప్పుడు యాంగిల్ ఆఫ్ రిఫ్రాక్షన్ ఎంత ఉంటుంది? 90 డిగ్రీ వస్తుంది. నౌ నెక్స్ట్ ఫిఫ్త్ రే డయాగ్రామ్ ఇస్ లెఫ్ట్ దేర్. ఫిఫ్త్ రే డయాగ్రామ్ లో ఏమవుతుంది చూడండి. లుక్ అట్ దేర్. I is greater than IC. IC means critical angle. I means angle of incidence. Angle of incidence is greater than critical angle. We are using the glass slab. Glass slab critical angle is 42 degree. అంటే 43 degree, 44 degree angle of incidence ఉంటే ఏమవుతుంది? Let's see what happens. See now. The refracted ray enters the same denser medium. The refracted ray enters in the same glass slab. The refracted ray totally not refracted. Instead of refracting, it gets reflect. అది రిఫ్లెక్ట్ అయిపోయింది. ఇన్సిడెంట్ రే ఏ మీడియంలో ఉంది, రిఫ్లెక్టెడ్ రే కూడా అదే మీడియంలో వచ్చేసింది. ఇట్ మీన్స్ హియర్ లైట్ ఈస్ నాట్ రిఫ్రాక్టెడ్. ఇన్ ద ఫిఫ్త్ కేస్ లైట్ ఈస్ రిఫ్లెక్టెడ్. వెన్ డస్ దిస్ హ్యాపెన్? వెన్ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ ఈస్ గ్రేటర్ దాన్ critical angle. In the case of glass slab తీసుకుంటే glass slab critical angle 42 degree ఉంది. ఒకవేళ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ 43 డిగ్రీ ఉండి ఇన్సిడెంట్ అయితే అప్పుడు ఆ లైట్ ఏమవుతుంది? రిఫ్లెక్ట్ అయిపోతుంది. So that's why fifth ray diagram shows you the concept of total internal reflection. Here light reflected internally and completely. That's why the fifth ray diagram shows the concept of total internal reflection. So 5 ray diagrams are shown to you to understand that how what happens if we are slowly go on increasing the angle of incidence and we are noting the angle of refraction. At one particular angle of incidence, angle of refraction is 90 degree. If angle of incidence is more than critical angle, light ray reflected. The fifth ray diagram individually shown to you here. See there, total internal reflection. Again, two medium are there, glass medium and air medium. IC means critical angle and angle of refraction is 90 degree, which is a critical angle concept. Now, అందులోనే రెడ్ కలర్ లో ఉన్న ఇన్సిడెంట్ రే చూడండి. See the red colored incident ray. That angle is greater than IC. Angle of incidence greater than critical angle undi. Now follow the red color. The red light is not refracted, it reflected, enter in the same medium. Look at the right side top. When the angle of incidence is greater than critical angle, angle of incidence means I, greater than symbol, critical angle C, the light gets reflected into the same denser medium. This phenomena is called total internal reflection. This is the definition for the total internal reflection. What is the definition? When the angle of incidence is greater than critical angle, the light gets reflected into the same denser medium. This phenomenon is called total internal reflection. Students, you have to notice one point. Point is, total internal reflection is just linked to the critical angle. Total internal reflection జరగాలంటే యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ వాల్యూ క్రిటికల్ యాంగిల్ కన్నా ఎక్కువగా ఉండాలి. ఎక్కువ ఉన్నప్పుడు లైట్ రిఫ్లెక్ట్ అవుతుంది, రిఫ్రాక్ట్ కాదు. అలా లైట్ రిఫ్లెక్ట్ అయితే ఆ ఫినామినాని టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ అంటారు. లుక్ అట్ హియర్. Next, further changes in the slide. Conditions for the total internal reflection. What are the conditions? Conditions for total internal reflection. First condition, rays of light must travel from optically denser medium, means denser medium, to the optically rarer medium. టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ జరగాలంటే ఖచ్చితంగా లైట్ రే డెన్సర్ మీడియం నుంచి రేర్ మీడియం కి పోవాలి, నాట్ ఫ్రమ్ రేరర్ టు డెన్సర్. వెరీ ఇంపార్టెంట్ పాయింట్ స్టూడెంట్స్. సెకండ్ కండిషన్ నీడెడ్ ఫర్ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్, ద యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ ఇన్ ద డెన్సర్ మీడియం మస్ట్ బి గ్రేటర్ దాన్ ద క్రిటికల్ యాంగిల్. అంటే ఐ షుడ్ బి గ్రేటర్ దాన్ సి. క్రిటికల్ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ క్రిటికల్ యాంగిల్ కన్నా ఎక్కువగా ఉన్నప్పుడే ఈ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ జరుగుతుంది. సార్ ఇవన్నీ జరిగితే మేము ఏం చేయాలి సార్? స్టూడెంట్స్, యు ఆర్ ఫిజిక్స్ స్టూడెంట్స్, యు ఆర్ యంగ్ సైంటిస్ట్, యూ కెన్ బికమ్ సైంటిస్ట్, యూ కెన్ అండర్స్టాండ్ ద సరౌండింగ్స్ phenomenon if you know the knowledge of all these. Which phenomena sir happening in my surrounding? Many things are happening in our surrounding. See, on a hot summer day, hot day, you are sitting in a bus is moving, there is a long road ahead. You see on the road there is a water, రోడ్ పైన వాటర్ ఉన్నట్టు కనిపిస్తుంది. మీ బస్ ఆ వాటర్ కి చేరుకుంటుంది, కానీ అక్కడ దగ్గరగా పోయినప్పుడు వాటర్ ఉండదు. ఎందుకు అలా కనిపించింది? ఎందుకు అలా ఏర్పడింది? దానికి కారణం ఫిజిక్స్ చెప్తుంది, సైన్స్ చెప్తుంది. కారణం ఏమంటే రిఫ్లెక్షన్ is the reason for the formation. Why? To know answer for every phenomenon happening or in our surroundings, we need to know the concepts of physics. My dear students, look at the definition of total internal reflection here. When the angle of incidence is greater than the critical angle, the light ray is reflected not refracted, reflected in the denser medium at interface. This phenomenon is called total. So, students, I try to make you understand with other example also, with other way. In another going to understanding the same diagram, student. We have taken